Yeah, recording. X plus y is equal to 60. Then we just have to say y is equal to 16 minus x. That's the first step to do. Then this one, let us say this is a product. We'll call it as a something like a p equal to x y cube. Then substitute y. So p equal to x into 16 minus x whole cube. So since this is maximum, we need to maximize b. So we should get the dp by dx. So best thing is to open the bracket. So x 360 cube. We can do that way also, or we can do x to the inside. Is that the better one, or is UV rule? I think best is UV rule. We'll go with the UV rule. So dp by dx equal to, using the UV product rule. So first differentiation of this is 1, 60 minus x whole cube u dash v plus x into 3 into 60 minus x whole squared into minus 1 because of the chain rule. So that gives us dp by dx equal to 60 minus x is there in both. So I take 60 minus x whole square as common. Then I have 60 minus x, and this is minus 3x squared, minus 3x squared. So we have to equate this to 0. So when we equate this to 0, so dp by dx has to be 0, dp by dx has to be 0. That's equal to 60 minus x equal to 0, or 60 minus x minus 3x squared equal to 0. So that means when I equate this, I get x equal to 60. Or now I have to solve this. So minus 3x squared plus x minus 60 equal to 0. So this, by the formula method also you can try, or by factorization also you can try. So 63s are 180. 180, you can have 18 into 10. This is still, this is equal to 9 into 2. 29s are there. 180. Best thing is we use the product rule. Sorry, we use the formula. Then I have minus 1 plus or minus square root of b square is 1 minus 4a, 4 into 3, 12, 12, 720 divided by 2. So minus 1 plus or minus square root of 721 by 2. Is our method correct? If we do 16, this is minus 3x, 3 into 16 minus 16 power of 4 minus 1. Yeah, this is correct. So 721, unfortunately, there is no perfect square root. So x equal to 60 is definitely a possibility. If x equal to 16, but then y becomes 0. So let me take this up. Let me take this up and then try it again. So that means definitely both are positive numbers. So x cannot be 60. X equal to 60 is invalid because y becomes 0. 0. So then we have to solve the other one, which means 60 minus x into 3x square. 60 minus x. Oh, that's where the issue. We have got 60 minus x from here, and this is minus 3x squared. So minus 3x squared plus x minus 60 should be equal to 0. So by formula, x is equal to minus 1 plus or minus square root of 460 to 40, 720, 720. So this is 180, 180 into 4, 720. That's correct. So 721 divided by 2. So, what's the square root of 721? Any idea?
No, sir. Should I check in the calculator?
Ah, can. I don't think you'll have a straight, without decimal number.
It's 26.851.
26.851.
Yes, sir.
Wow, wow. So we are doing question, this is 14, right? So 14. So somewhere it's not correct. The answer is 45. So I'm just looking at where we went wrong. X into 16 minus x cubed. This is u dash into v plus uv dash. So this is x into v dash 3 into 16 minus x whole square and then minus 1. So we got 16 minus x whole square is common out. Then you got 16 minus x. Then you got, oh, minus 3x, not minus 3x square. Yep, there's a small mistake here.
Yes, sir.
So this one is from here, this entire thing is, this is not correct, this is not correct, this is not correct. So this one will be 16 minus x minus 3x, and therefore this or 16 minus 4x equal to 0, and therefore x is equal to 15. If x equal to 15, y is equal to 16 minus 15, which is 45. Okay. So one of them is 45, other one is 15. That's the answer. So this is about the 14. So 15th question. 15th question is similar. Only thing is the sum of the numbers is 35. X plus y is equal to 35. And we need to maximize x square into y to the power of 5. Maximum x square into y to the power of 5. So same, let's assume p is equal to x square y to the power of 5. So here you may think like what you want to actually uh, replace can be y or x. I want to knock off y because it's better to have everything in x. 35 minus x. Therefore, you'll have p equal to x squared into 35 minus x whole to the power of 5. So dp by dx equal to same UV rule 2x 35 minus x whole to the power of 5 plus x squared into 5 into, so 35 minus x whole to the power of 4 into minus 1. So again take off x and 35, x and 35 minus x whole to the power of 4 common. Then from here I'll have 2. From the second one I'll have minus 5x. So now we have three possibilities, either x equal to 0 or 35 minus x equal to 0 or 2 minus 5x equal to 0. So in all these cases, here also you said x and y must be positive numbers. X and y must be positive numbers, the sum is 35. So this can't be the case, this can't be the case because they are not positive, one of them will be negative. Okay. Then this gives us x is equal to 2 by 5. So 2 by 5 is positive, yes it is positive. If x equal to 2 by 5, y is equal to 35 minus 2 by 5, then you will have 5 5s of 25, 5 3s of 5 15 plus 2 is 175 minus 2 by 5. So it's 173 by 5. So write as a mixed fraction, 5 3s are 15, 23, 5 4s are 23 by 5. So if you add these two, you'll get 35. And if you have one of them to be like x squared right to the power of 5, that will be the maximum. So that is what is the 15th question. 16th question, written here, x plus y is equal to 6 and x cube plus y cube is to be minimum. This is 16th question. So y is equal to 16 minus x. Substitute again, let's say p is equal to x cube plus y cube. Substitute that p is equal to x cube plus 16 minus x whole cube. So dp by dx equal to 3x squared plus 3 into 16 minus x whole squared into minus 1. So this should be 0. That means 3x squared minus 3 into 16 minus x whole squared equal to 0. So 3 gets cancelled. So x squared equal to 16 minus x whole squared. So then when we open the bracket here, x squared equal to 256 plus x squared minus 32x. So x squared gets cancelled. So 32x is equal to 256. X is equal to
So
256 divided by 32. So 32 3/8 or so x is equal to 8. So once we got x is equal to 8, y is equal to sum is 16, therefore y is also equal to 8. That is the 16th question. 17th question. 17th question is little 17th onwards, the exam type questions. Definitely you may have a question coming from this kind of stuff. Okay, so 17th, I have to write the question. That's why I write the question and then I'll explain that. A square piece of tin of side 18 centimeter. So there is a square piece of tin side is 18 centimeters. This is a tin. And from this, it is to be made into a box. It is to be made into a box like this, like with the top open, like our sweet box or something like that. So it is to be made like this. So by cutting a square from each corner, so they have to cut exactly same square. Square size must be same in all the four corners. After they remove this, then they will fold it up. So this side they will fold it up, you will get this kind of a box. So what should be the side of the square to be cut off? So he is asking this small square, if you say this x, and you have to give the what must be cut off so that the volume of the box is the maximum. So volume of this box is maximum. So now we have to get from this x. So x is cut here, x is cut here. That means this side is 18 minus 2x. 1x and 1x cut here. So this is also 18 minus 2x because it's a square. This fellow is x because x is the height. So now we have got the box. So that v is equal to length into breadth into height. So this may be length, this may be breadth, this is the height. So that's equal to 18 minus 2x into 18 minus 2x into x. So this is to be maximized. So we will say v is equal to 18 minus 2x whole squared into x. Now do dv by dx. So by uv rule, product rule, 1 into 18 minus 2x whole squared plus x into 2 into 18 minus 2x into 2 into minus 2 because minus is there. So that's equal to 18 minus 2x whole squared. This minus, so you'll have minus 4x into 18 minus 2x. This is to be equated to 0. So dp by dx should be equal to 0. Then we have 18 minus 2x whole squared minus 4x to 18 minus 2x equal to 0. So 18 minus 2x is taken common. Then we have 18 minus 2x minus 4x equal to 0. So 18 minus 2x equal to 0, or this inside the bracket 1, 18 minus 6x equal to 0. 18 equal to 2x, 18 equal to 6x. So x equal to 9 or x equal to 3. Let's see, it cannot be two values, one of them is invalid. So now if x equal to 9, then you will have 18 minus x. So the sides will be sides of the box would be 18 minus x, 18 minus x, and x. That means this is 9, 9. Actually, it's 18 minus 2x, isn't it? So it's not 18 minus x. So if you look at the top, our dimensions are 18 minus 2x. So 18 minus 18, 18 minus 18, and 9. So that becomes 0, 0, 9. So it's invalid because you can't have 0 side. Therefore, x must be equal to 3. Then sides of the box will be 18 minus 6, 18 minus 6, and 9. So it's a 12, 12, 9. So which is a correct one. So this is the simplest of all the questions coming from 17 onwards. So now we go to the 18th question. So instead of writing the question, I will explain this way only. I will explain what is required. You can actually see the textbook for the actual question. Rectangular sheet of tin, 45 centimeters by 24 centimeters. Question is almost similar to the previous one. There we had a square in a 17th question. Here it is a rectangle. So rectangle of this is given 45 centimeters by 24 centimeters. So from this sheet, it is to be made into a box without top by cutting off a square from each corner and folding up the flaps. So what should be the square to be cut off so that the volume of the box is maximum? So same approach. We assume this is x, this is x, this is x centimeters, x centimeters, x centimeters, x centimeters. And this side also x, this side also x, this side also x. So the box will be something like that. So now this side will be 45 minus 2x. This side will be 24 minus 2x centimeters. And this is x centimeters. Therefore, volume V equal to 45 minus 2x into 24 minus 2x into x. This is what a volume. We need to maximize this volume. So in this case, best to multiply everything then rather than using UV rule. Okay? So I would suggest to multiply. Now when I try 45 into 24, 24 fives 120, 24 fours 96, 96 plus 400, 108, 1080. So I have 1080. 45 into 2 90x, 24 into 2 48x. So minus 138x plus 4x square multiplied by x. So V equal to, open the bracket, 1080x minus 138x squared plus 4x cubed. Now we differentiate dv by dx. 1080 minus 138 into 2x plus 4 into 3 x squared. So we have 1080 minus 276x plus 12x squared is what we got. We have to equate this to 0. dv by dx must be equated to 0. So we have 12x squared minus 276x plus 1080 equal to 0. I think it should be divisible by 12. So divide by 12 or take 12 common, whichever it is. So you get x squared minus 2, 3, 23x plus 12, 9, so 19 equal to 0. So x squared minus 18x minus 5x plus 19 equal to 0. So it's x minus 18 into x minus 5 equal to 0. So x equal to 18 or x equal to 5. So if I use 18, if x equal to 18, then the sides would be 45 minus 2x, which is 45 minus 36, which is equal to 9. Then 24 minus 2x, this is 24 minus 36, which is negative, so not positive because it's negative. So the other value must be x equal to 5 is valid. Therefore, 24 minus 2x is equal to 14. 45 minus 2x equal to 35 and x is equal to 5. So 35 by 14 by 5 centimeters cube is the volume, or each side is as given. So this is the question number 18. So what should be the side of the square to be cut off? And the square should be 5 centimeters. This is what we can see. Answer is x is 5 centimeters. This is the answer. Then 19th question. Show that of all the rectangles inscribed in a given fixed circle. I will write this question because this is shorter one. It's not such a big question. So let me see, is a big thing what we have done. Yeah, so let me take it to the next page. 19. Of all, show that I think the first one is show that of all rectangles inscribed in a given circle. This is the keyword. Okay? In a given fixed circle, this given is a keyword. Given fixed circle, the square has the maximum area. The square has maximum area. So that means if I draw a circle, you can have different types of rectangles. This can be one rectangle, this can be one rectangle. So you can have many rectangles like that. Of all the rectangles, so one square like this shape is the one which can have maximum area, is what we need to be proving. So in this question, he is not asking what is the side, anything, nothing is asking. Okay? So we have to assume first. So let's say, I think I'm erasing this part. So let a circle of radius r root 2. You can have r root 2 or a root 2, whichever. It's only just, I'll tell you why a root 2. A root 2 is a circle of knot radius diameter. A circle of diameter a root 2 is drawn. So that is, so diameter is that. So we are just taking this diameter like this. This is what a diameter will be. So the radius will be a root 2 or whatever. Now if this is a diameter, now construct a square, or draw a square, inside circle with a root 2 as diagonal. So now I'll tell you why we consider, if I take any square with a, then this also will be a. Then by Pythagoras, this diagonal will be, x will be square root of a square plus a square. So you will get a root 2. That is the reason why I assume this diameter to be a. So now a root 2 is a diameter, diagonal. So you will have, that implies the side of the square would be a centimeters. A centimeters. So now I can draw that basically. So you will, this with the diagonal, that means you will have one side would be like that, and then the other sides would be, this is another side, and this is another side, and this is another side. So this will be a, this will be a, this will be a, this will be a. So let A be area of square. Then A equal to a square. So do you see any better way you could have done it?
Uh,
Because the question itself asks for rectangles, but then we are assuming to be a square, no?
yes, sir.
So this is definitely not the best way to do it. So that's why I'm I have to consider a rectangle. So let me clear this stuff. So we have to start as a rectangle, not as a square. So that means entire thing, entire thing has to be cut off. So if you assume square and I prove that it is a square, then there is no big deal. We have to take this rectangle, and from the rectangle, finally we should say both sides must be equal to each other, and that's how you get as a square. That's what you should be proving it. Okay, so these are like, how do you model is important, like how you assume that to be is important. Okay, now here we have to write some information. So let a rectangle of length L and breadth B is inscribed in a circle such that the diagonal the diagonal of the rectangle forms as diameter of the circle. So that's the only thing we are now assuming. So we have this, and we have a rectangle, and this is the diagonal. So since it's a diagonal and diameter, so the center will be here. So I'll mark this as A, B, and this is length, this is C, this is breadth, this is length and all stuff. So now it is said that for a given fixed circle, this is what, these are the words he has used. Given fixed circle means diameter is fixed, means diameter is constant. So how do I get diameter? AC is the diameter of circle. The AC is diagonal of ABCD, rectangle ABCD. So because it's a diagonal of ABCD by Pythagoras, because this is 90 degrees, the diagonal D equal to, that's a diagonal diameter also, therefore D is equal to square root of L square plus B square. So D is constant. Why? Because you said it's a given circle. Is given fixed circle. So he said this is a given fixed circle and this diameter rectangular showed all rectangles which have been given fixed circle. The square has a maximum area is what we need to prove it. So once this is fixed, then I have to be differentiating this, and then from that you have to be calculating what must be the length and what must be the breadth kind of a stuff. So since D is fixed, both length as well as breadth can be changing. Okay. So then I have to definitely, if D is fixed, that means the area is fixed. So if D is fixed, that means L and B are changing and D is fixed, which means area of rectangle is fixed. So what does it area of this rectangle is fixed mean? So L into B is a constant. So if I have one of them, the other one will be known to you. So that means B is equal to K by L. So let's
Yeah.
now substitute that D is equal to square root of L squared plus B squared. That's equal to square root of L squared plus K squared by L squared. So you will have square root of L to the power of 4 plus K squared divided by square root of L squared. That's equal to square root of L to the power of 4 plus K squared divided by L. So this is what the D is. So I will just say dl is equal to square root of L to the power of 4 plus K squared. I will differentiate this with respect to L. Differentiating. So when I differentiate this with respect to L, I'll get D equal to, this is 1 by 2 root of L to the power of 4 plus K square multiplied by differentiation of L to the power of 4 is 4L cube. So D is equal to, now this 2 ones are 2 2s are. So you'll have L cube divided by square root of L to the power of 4 plus K square. This is what as a diameter given. Then you can consider this, but we know D is equal to square root of L square plus. So we have to substitute that, but we know that D is equal to square root of L square plus K square by L square. So you will have square root of L square plus K square by L square equal to L cube divided by square root of L to the power of 4 plus K square. So Then when you simplify this, you will get L to the power of 4 plus k squared divided by L equal to L to the power of cube divided by square root of L to the power of 4 plus k squared. So cross multiplication, you will get L to the power of 4, that is this cross multiplication. Then you will have L to the power of 4 plus k squared, which means k squared can be 0. Understand it? 12 square. Then this implies that d is equal to square root of L squared. So that means the breadth would be 0. It is an invalid case. You can't have k squared to be 0 because L is equal to L, B is equal to k by L. LB is equal to k. Okay? So this is an invalid condition. That's why let's look at what is that. Show that all the rectangles inscribed in a given pixel circle, the square has a maximum area. So either L square plus B square is constant. When you take L square plus B square, have we maximized the area? We didn't maximize the area. Okay, and that's the reason we are learning. We got the area, we fixed the area, we didn't maximize the area. So we are going back to where we could have done in a different way. So here d is equal to fixed, and we should have taken from here the d value. Okay, what it means. So LB cannot be fixed. This cannot be fixed. This is exactly what we have done. This is area of the rectangle. We said fixed, but we need to be maximizing it. So if you fix that, then you cannot maximize that. All right. So, and hence, that's the reason, in fact, I gave you now from beginning itself. So LB is the one we need to be maximizing. So let's say the area A is equal to LB, and this is what we need to maximize. So B is to be eliminated. How do we eliminate B? B is to be eliminated from D equal to S square plus B square. So from that we get B square equal to D square minus L square. B square equal to D square minus L square. Therefore, B is equal to square root of B square minus L square. In this, B is fixed. That is how we should be doing it. Okay. So
Okay,
this
sir.
entire, yeah, this entire thing is invalid. Okay, this entire thing is invalid. You can't do with the fixed one. Okay. What I'll do is I'll just clear it up. Entire thing I'll clear it up and then I will redo it. Okay? That is it. Question number I take time answer 20x. This is 19. So let a rectangle of L and B is inscribed such that diagonal of the rectangle is same as diameter of the circle. So we have this, we have this, we have this. This is L, this is A, this diameter, this is B, AC is equal to B, it is fixed and constant. So D is equal to, this is D, square root of L square plus B square. That implies B square equal to B square minus L square. So B is equal to square root of B square minus L square. So the area of A is the area of rectangle, that's equal to L into B. So A is equal to L into square root of B square minus L square. So now we have to maximize dA by dL. So the first UV rule, L equal to 1 square root of B square minus L square plus L into 1 by 2 root D square minus L square minus 2L. So you get square root of B square minus L square plus, rather minus, these two gets cancelled and we'll have L square divided by square root of B square minus L square. So this is to be equated to 0 for this to be maximum. So dA by dL to be 0. Therefore, square root of B square minus L square minus L square divided by square root of B square minus L square equal to 0. So which means square root of B square minus L square. Are we getting the similar thing again? Let's see. So that's equal to L square divided by square root of B square minus L square. So if you multiply this, there must be some catch, somewhere something we are missing, I think. Let me, we said L into, this is L into minus 2L, so L square, and this is this. So we got L square equal to D square minus L square. So there's one more L must be coming. L into B is square root of D square, so L square plus B square, this is correct. So this is also correct, 1 by 2 root B square minus L square into minus 2L. So 2 gets cancelled, 1 by 2 root, and this is minus 2L. Then L equal to B. So this is nothing but B. Yeah, we got it. Okay. So your previous case also we got it, but only thing is we didn't substitute. Okay. So D square minus L square is nothing but square root of B square equal to L square divided by square root of B square. So that implies B square equal to L square. So therefore B is equal to L, means it is the rectangle is a square. The point now is we just said, but how can we say, this is the important point to get the marks, must do second derivative to show the area or the P is maximum. P, right? A is maximum. That means I should get second derivative to be negative. So what is the first derivative? dA by dL is this. dA by dL is this. So dA by dL equal to square root of d square minus L square minus L square divided by square root of d square minus L square. Now I should definitely show that the second derivative, when I differentiate this, I should get negative value. Okay. So doing d square A by dl square, that's equal to 1 by 2 root d square minus L square into minus 2L, that is for this. And for this is a u by v rule, quotient rule. So I put a bracket and then I will write this v squared, that means d square minus L square. This is the trouble part. We can't stop, we have to do this second derivative. Okay. So u dash is 2L into u dash v is square root of d square minus L square minus uv dash L squared into v dash is 1 by 2 root d square minus L squared into minus 2L. You don't have to be completely doing, but you have to simplify to some extent. This 2 gets cancelled. You have minus L divided by square root of d square minus L square minus. So from here minus comes, this comes. So you write this as 2L square root of d square minus L square. Here becomes plus L square divided by square root of d square minus L square divided by d square minus L square. Now you have to say, pick each one and then tell. So inside this bracket is positive. Whatever value of d and l you take, this entire thing is positive. Therefore, you get some negative value, negative, minus, negative. So you're getting overall negative value. So since overall dp d square a by d l square is negative, area is maximum.
Yes, sir.
In fact, we have to do these steps for all the questions down below, 20, 21, 23, all questions. That's why each question, this is a 5-mark question. If at all you get, this is a 5 marks question from 19 onwards. Okay? So it's
Sure.
a huge steps. So taking to the next page. Question number 20. Show that the right circular cylinder, show that right circular cylinder, right circular meaning it's a vertical cylinder of a given surface. I am putting that in the red. Of a given surface. That means surface area is given. Given surface and maximum volume, and maximum volume is such that height is equal to the diameter of the base. Height equals diameter of the base. So if you read the question, actually show that height equals the diameter. That's what you should be doing. So let's draw a right circular cylinder. This is the right circular cylinder, and this is the diameter of the base, and this is the height of the cylinder. So if this is the diameter, radius will be d by t. So you said given surface. Now we need to first work it out. What is the surface area of the cylinder? Surface area of the cylinder equal to base area and top area. That means pi r square of bottom, another pi r square of the top, plus 2 pi r h of this curved surface. So you'll have 2 pi r square plus 2 pi r h. That's equal to, take 2 pi r common, we'll have r plus h. This is what is the surface area. Let me call it S. So this is fixed. So this is fixed. And we need to maximize the volume. Volume equal to pi r square h. So this is to be maximized. So in all the cases, what we do, we have two variables, r and h. We have to eliminate one of them so that we can do a dv by something. That's what we need to do. For that, we use this to eliminate that. So S is a constant thing, whichever you want to make. If you want to make H is a constant, which you want to eliminate, then we will write as, from here you can write 2 pi r h equal to S minus 2 pi r square. Then H is equal to S minus 2 pi r square divided by 2 pi r. So this is the important step. And this is what I am substituting into here. Okay. So I have to substitute this. Therefore, V is equal to pi r square, H is S minus 2 pi r square divided by 2 pi r. So this pi gets cancelled, one r gets cancelled. So you will have half, this 2 is from here, r into s minus 2 pi r square. So this is the volume with only one variable r. So you can actually open this bracket and write half into rs minus half into r into 2 pi r square. So then 2 gets cancelled. So what we have is v is equal to half into rs minus pi r cube. Now we do dv by dr. So this is nothing but half s, because s is fixed, r is what we are using as a variable, minus pi into 3 r square. So half s minus 3 pi r square. But we have to maximize volume. Therefore, dv by dr should be equal to 0, which means half s equal to 3 pi r square. So we need to substitute what s is equal to. So s is equal to, we have done already, 2 pi r into r plus h. 2 pi r square and 2 pi r h. This is what s. So this 2 gets cancelled. That's equal to 3 pi r square. Now open the bracket, we get pi r square plus pi r h equal to 3 pi r square. So take this pi r square to the other side. So pi r h equal to 2 pi r square. So pi gets cancelled, one r gets cancelled. So that will give you h is equal to 2r. 2r is nothing but b. Therefore, h is equal to the diameter of the base. We have proved assuming that it is maximum. Now, do the second derivative test. Do the second derivative and show that it is negative. It is negative for any value of r and h. That's what we need to do. I'm writing in red because we cannot forget this. Many students don't write this last part and end up losing 2 marks for that. So dv by dr is half s minus 3 pi r square. Half s minus 3 pi r square is the dv by dr. So differentiate one more time. Differentiate with respect to r. So you get d square v by dr square. The first one is 0 because surface is fixed, minus 3 into 2 pi r. So what we get is minus 6 pi r. So we are clearly seeing that d square v by dr square, d square y by dr square is negative for any value of r. Therefore, v is maximum for h is equal to 2r. Got it?
Yes, sir.
So, like this, all we have to consider all the questions in a similar way. Okay? The next question is, of all the closed cylinder cans, right circular. Right circular means vertical. You don't need to be really worried about that word. Of a given volume of 100 cubic centimeters, find the dimensions of the can which has a maximum surface area. This is a little bit of a reverse thing. I will complete this question, then only we will end the class. Is that okay? I'll finish the 21. Or you are busy. Sam,
Yes,
should I complete 21 also, or next
so
question
you
also?
can complete, sir.
Okay. So we go with the 21 question. of all closed cylinder cans of all closed cylinder or cylindrical or cylindrical cans of a given volume, like of given. So the given is a keyword. Given volume of 100 cubic centimeters. 100 cubic centimeters. Find the dimensions of the can. Which has a minimum surface area. Minimum surface area. So two keywords, one is a given, other one is a minimum. Okay. So V is the volume of the cylinder. That's equal to pi r square h. So we are given 100 equal to 100 centimeter cube equal to pi r square h. Therefore, h is equal to 100 divided by pi r square. We got the h value. Now we need to take the surface area. Surface area S is equal to 2 pi r square plus 2 pi r h. That's how we did in the previous. So now we substitute h value into this. S equal to 2 pi r square plus 2 pi r into 100 divided by pi r square. So the pi gets cancelled, r gets cancelled here. So we got 200 divided by r in that. So S is equal to 2 pi r square plus 200 divided by r. So we need to find ds by dr and then d square s by dr square. So I'll keep the thing here for d square s by dr square. So first one is ds by dr. Differentiating. Then you get 4 pi r. That part is easy. For this, 200 into minus 1 by r square. Or 1 by r, differentiation is minus 1 by r square. So you got 4 pi r minus 200 by r square. So ds by dr has to be 0 for minimum or maximum. Or maximum.
Okay, sir.
So we equate this to 0. So that means 4 pi r equal to 200 by r square. So we'll get r cube equal to, so is we have everything correct only, right? R cube is equal to 200 by 4 pi. So this is what the r value. R will be cube root of, so first we'll say 50s. R will be cube root of 50 divided by 5. So we have the R value because he asked us to find out the dimensions. So R value we have to find, H value also we have to find. H values, we have got H value to be 200 by 100 by pi r square. So H is 100 by pi r square. So here from here R equal to this, R square will be 2 by 3 something like that. So R into R square divided by R. 100 divided by 5 into, this is 2 by 3, 50 to the power of 2 by 3 divided by 5 to the power of 2 by 3. We'll come to this part of it. We'll say first d square s by dr square, whether this is equal to 0 negative, positive, it should be positive. So when I differentiate this, I get 4 pi minus 200. So for r to the power of minus 2, that means r to the power of minus 2, that means minus 2 into minus 2 minus 1 r by r cube. So you get 4 pi plus 400 divided by r cube. So this is positive value. So since d square s by dr square is positive, the surface area S is minimum. So we have done that part. Now let us look at the dimensions. For the dimensions, we will just check whether we have done it correct or not. 2 pi r square plus 2 pi r h, 2 pi r into h, 100 by pi r square. So 100 by pi r square, pi gets cancelled, 1 r gets cancelled. So you have 200 by r and minus r 200 minus 1 by r square. So this is 200 by r square. This is also correct. So 4 pi r is 4 pi r. So you get r cube is equal to 200 by 4 pi. So 4 50 sir. So 50 by 5 and yeah. So this is what the correct. Everything else is correct. So you just want to verify the answer in the textbook. 21 question. 21. Yeah. R is equal to 50 by 5 to the power of 1 by 3 and H is also, he just puts it 2 into 50 by, because we already know that H is equal to 2R for the right circular cone. We have done that for that. So that's why it just leaves that 2 into 50. We can simplify this also. Get that same thing. So this is equal to 100 into 5 to the power of 2 by 3 divided by 5 into 50 to the power of 2 by 3. 50 to the power of 2 by 3. So we've got 100 and 5. If you want to take this out, 100 into 2 by 3 minus 1. That means 5 to the power of minus 1 by 3. This will be 50 to the power of 2 by 3. You can read this way also, simplifying it. Here also they give the marks. Actually, even if you do like this also, you get the marks. So this is the final answer. Since it is given as a centimeters, we need to write centimeters. This also is to be written in centimeters. All right.
Yes, sir.
So we can stop here today. Okay. Next class will be Wednesday.